Hi everybody, I'm David.
I'm Haley.
We're here in the Intelligent Concrete Laboratories today, and we've had some questions come in. We've had people ask us things occasionally. And Haley, what's up for today?
How strong is too strong?
How strong is too strong? Well, you know, the easy answer, the practical answer, is to make concrete stronger, we have to put in something that makes it stronger. We have to put in more Portland cement, to put in something, other product that makes it stronger. And what do we suppose is the most expensive ingredient that goes into concrete?
Cement.
Portland cement is by far the most expensive ingredient that goes into concrete. So, you know, I don't want to use an offensive term, but this is a term that's used a lot in the industry.
I'm nervous.
And when I was out in the last century, we used to talk about this a lot. We say, "Oh, let's go hell for stout."
Oh.
You know, we okay with that?
Mm-hmm.
Okay,
Yeah.
good. Yeah, I can see a look in your eyes as I was saying that. So hell for stout, not good.
Yeah.
You know, costs money.
Yep.
And so that's the practical side. And you know, concrete that's stronger and stronger and stronger,
It's brittle.
it may not be better for the purpose that you want to use it for.
It's scary.
Yeah, most of the literature contends that the very strong concrete has lower failure strains.
Mm-hmm.
That is to say, it's more brittle. They say that it has higher modulus. That is to say, it will resist deflection better, but it's still more brittle.
Mm-hmm.
So brittle's not good. I mean,
No,
concrete,
less time for people to get out.
there's that, and then, you know, brittle causes cracks. I mean, that's where cracks come from. If we can't get much strain and compression, if it's brittle, then we get cracks sooner in compression.
Mm-hmm.
We really don't want that, and of course, tension's a whole other story. We don't need to get into that. So yeah, costs money. From the design side, it may not be the product we want.
Mm-hmm.
It just may not. I mean, if we're building a bridge beam, designing a bridge beam or something like that, we probably want a little bit of deflection, allowable deflection. We want the L over 360 or whatever, allowable deflection to give a little give. If you try to make things absolutely, completely, totally rigid, then that may not be good. You know, dynamic loads may hurt it. On the blast side, of course, that's a whole nother can of worms there. You know, blast loads are very quick. They're very high peak, but generally they're very short in time period. So if in the few microseconds if you can absorb that initial shock, then you're good.
Yeah.
You're good. And one way to absorb shock is to move.
Mm-hmm.
It's like a spring in a car or anything like that. It helps absorb that shock. And so super brittle against blast, maybe not the best idea.
Yeah.
Maybe one little give. Buildings subjected to earthquakes.
Mm-hmm.
But I don't want them super brittle. I want them to have a little give and take,
Right,
you know, absorb some of that motion and then damp it out with material damping. So yeah, we just can't make everything super rigid, costs too much, and may not be the right for the design that we're designing. So design is about designing for the problems you're faced with.
Mm-hmm.
You know, it's not a one size fits all. It's not a just do this for everything. That's how designers make their money.
Yeah.
Is to take a problem and solve it through some form of design.
Yeah.
So yeah, we don't want to get crazy with strength.
Yeah.
Yeah.
At Oklahoma State, Tyler, in concrete, I studied under Dr. Tyler Lay at Oklahoma State, and his big thing was to look at concrete as a holistic. You want to include durability, you want to include strength, of course, but there's so many more aspects to concrete that are important. You don't just want the strongest guy on your team.
That's right, absolutely. That, again, that's well stated. So
Yeah.
good point.
Yeah.
Yeah.
Thanks for watching, everyone. Hope you learned something or multiple things. Thanks for watching. Don't forget to like and subscribe, ding that bell for notifications. Go concrete!
Beat asphalt.